Unit 2b, Lesson 5, compare properties of functions. So we're going to look at quadratics, absolute values, look at the graphs of them, the given equations, identify key parts, and compare those two functions when given in different forms. First example, which function has the greatest y-intercept? So we're given some information. Out of these four options, we want to determine which one has the greatest y-intercept. So in equation 1, we have f of x equals 3x. We're not adding or subtracting anything at the end, so we know the y-intercept has to be 0. In the second equation, that is our standard form. If we want to find the y-intercept, we can use the cover-up method. So we have 3y equal to 12. If we take 12 divided by 3, for number 2, that y-intercept is going to be 4. For the third one, the line has a slope of 2 and passes through the point 1, negative 4. So we have to use point-slope form. Y plus 4 is equal to our m value, which is 2, and then x minus 1. Now if we go through and solve, we get y plus 4 equal to 2x minus 2. Y is equal to 2x. If we would subtract 4 to the other side, we get negative 6. So we could see for 3, the y-intercept is negative 6. And then in our graph, if we look, 1, 2, 3, 4, it looks like 5. The y-intercept for this graph would be 5. So which of these four has the greatest y-intercept? It would be choice 4. 5 is greater than 0, 4, and negative 6. Now to the second example. It tells us the graph representing a function is shown below. So we have some sort of parabola. We want to determine which function has a minimum that is less than the one shown in the graph. So the minimum value for this graph would be negative 1, 2, 3, 4, 5, 6, negative 7. So we have to determine which of these options is going to have a minimum that is less than negative 7. Well, there's a couple we can eliminate right away because these absolute values, we can determine the minimum relatively quickly. Both of these are positive. So if we look at the vertex, that's going to be the minimum value. So the vertex in this case would be negative 3, negative 6. So this has a minimum of negative 6 that is not going to be less than negative 7. The minimum for number 4 is going to be 2. So that is not going to be less than negative 7 as well. So we can eliminate that choice. So it's narrowed down to 1 and 3. So for number 1, I'm going to find the vertex of the graph. So it would be x equals the opposite of b over 2 times a. So our b value is negative 6. The opposite of that is positive 6. So we have 6 over 2 times our a value is 1. So the x coordinate of our vertex is 3. Now if we plug 3 in for x, we can find the minimum value. 3 squared is 9. Negative 6 times 3 is negative 18. So you have 9 minus 18, which is negative 9. Negative 9 plus 7 is negative 2. That would be the minimum value. And I know the vertex is going to be the minimum value for this parabola because the a value is positive. So this graph is going to open up. So it cannot be choice 1 either. By elimination, it must be option 3. If we go through and find the x-coordinate of the vertex, it would be 2 over 2 times 1, or just an x value of 1. Now if we plug 1 in for x, 1 squared is 1, minus 2, 1 minus 2 is negative 1, negative 1 minus 10 is negative 11. Negative 11 is less than negative 7, so it has to be choice 3. Now to the last example, the function h of x, which is graphed below, and the function g of x equals 2 times the absolute value of x plus 4 minus 3 are given. And then we have some statements. We want to determine which statements about these functions are true. So we have g of x has a lower minimum value than h of x. For all values of x, h of x is less than g of x, and for any value of x, g of x is not equal to h of x. Okay, so we need to analyze these two different graphs. If we have h of x graphed already, and the equation for g of x it might help to graph g of x on the coordinate plane to better analyze these values. So the first thing I did was graph the vertex of g of x, which would be -4, -3. Then we have a slope of 2 essentially, so we go up 2 either way, or you could quickly get a table of values, plots, and points and see the pattern. So we have the graph of the absolute value for g of x. Now we want to look at the statements. The first one, g of x has a lower minimum value than h of x. Well, the minimum value of h of x is 2. The minimum value for g of x is -3. So g of x is lower. That would be true. For the second option, for all values of x, h of x is less than g of x. So for all values of x, the y values in h of x are less than the y values in g of x, and that's going to be false. If we look at the x value of -4, h of x is a value of 2, g of x is a value of -3, 2 is not less than -3. That second statement has to be false. Then the third statement says, for any value of x, g of x is not equal to h of x. Essentially, what this is getting us to analyze is, are these two graphs going to intersect? Is g of x ever going to intersect h of x? And if we look at this graph, these have the same slope. If we look at the change, this goes up 2 over 1, up 2 over 1, up 2 over 1. Same thing here, up 2 over 1, up 2 over 1. That pattern is going to continue. These two graphs are never going to intersect. So for any value of x, g of x is not going to be equal to h of x. That's a true statement. Those two graphs are never going to intersect. G of x will never be equal to h of x for a single value of x. So statement 1 is true, statement 3 is true. So the correct choice would be choice 2. 1 and 3 are true. Number 2 is false.